Well, now look at some applications of the distance formula. The first thing that we're going to do is, using the distance formula, we're going to establish whether 3 points are collinear or not. Before establishing whether 3 points are collinear or not, we're going to go back to a geometry postulate. We're going to draw a segment. We're going to put 3 points on the segment. We'll call them X, Y, and Z. From geometry, we know that the length of segment XY plus the length of segment YZ is equal to the length of segment XZ. This is known as the segment addition postulate. So, if 3 points are collinear, the sum of the lengths of the two shorter sides is equal to the longer side. And that's the goal for us. We're going to erase the postulate, and now we're going to find the distance from A to B. So AB, I'm going to write the point 5, comma 0, the point negative 7, comma 3. The change in X, to get from 5 to negative 7, we need to subtract 12. So this is our change in X. What about the change in Y? To get from 0 to 3, we add 3. This is our change in Y. Length of segment AB is going to be equal to the square root of the change in X squared plus the change in Y squared. This is negative 12 squared plus 3 squared, it is equal to the square root of 153. What we're going to do now is we're going to simplify the square root of 153. We're going to divide by 3. This is 51. We're going to divide by 3 again. This is 17. We're going to divide by 17 and again 1. We notice the pair of 3's, which means that the square root of 53 is the square root of 3 times 3 times the square root of 17. So 3 square root of 17. Now we find the length of segment BC. Same procedure. B has coordinates negative 7 and 3. C has coordinates 1 and 1. The change in X is positive 8. The change in Y is negative 2. The distance from B to C is the square root of the change in X squared. So 8 squared plus negative 2 squared. It is equal to the square root of 68. This 68 is 2 square root of 17. So I skipped the work for it. Then the last thing that we're going to do is we're going to find the distance between A and C. We're going to write down the coordinates of A, 5, 0. We're going to write down the coordinates of C, 1, 1. We're going to notice the change in X, negative 4. The change in Y, positive 1. We're going to apply the Pythagorean theorem. AC is equal to negative 4 squared plus 1 squared. AC is equal to the square root of 16 plus 1. It is the square root of 17. The last thing that I notice is that AC plus BC is equal to AB. In other words, the square root of 17 plus 2 square root of 17 equals 3 square root of 17. So this is one application. Using the distance formula, you can see whether 3 points are collinear or not. I'm going to erase the board because I need this space. And we're going to now look at a different application. We're going to figure out whether the triangle is isosceles, whether the triangle is right, and if it's right, we're even going to find its area. As always, the first thing that we do is we find the lengths of the segments. First, the length of segment AB. A has coordinates 4 and negative 5. B has coordinates negative 2 and negative 8. To get from 4 to negative 2, we have to go 6 to the left. From negative 5 to negative 8, we need to go 3 down. We figured out our change in x. We figured out our change in y. So now we're ready to figure out the length of segment AB. It is negative 6 squared plus negative 3 squared. This is equal to the square root of 45. We're not going to simplify this time. We're going to move on. Now we're going to find the length of segment BC. B has coordinates negative 2, negative 8. C has coordinates negative 8 and 4. To get from negative 2 to negative 8, you need to go 6 to the left. That's your change in x. To get from negative 8 to 4, you need to go 12 up. That's your change in y. You have your horizontal leg and the vertical leg of your right triangle. To find the length of segment BC, you apply the Pythagorean theorem and you get negative 6 squared plus 12 squared. BC is equal to the square root of 36 plus 144. BC is equal to the square root of 108. We have to find one more side. That is, we need to find the length of segment AC. A has coordinates 4, negative 5. C has coordinates negative 8 and 4. To get from 4 to negative 8, you need to go 12 to the left. So your change in x is negative 12. To get from negative 5 to positive 4, you need to go 9 units up. Your change in y is positive 9. What about the length of AC? It is the square root of negative 12 squared plus 9 squared. This is the square root of 144 plus 81. This square root of 225. This is a nice 15, but we'll leave it alone. So we'll just keep it as square root of 225. Well, we are now ready to tell whether this triangle is isosceles or not. So we're ready to do part A. Is triangle ABC isosceles? No. So triangle ABC is not isosceles. An isosceles triangle has two equal sides, two congruent sides. AB does not equal AC, does not equal BC. Our triangle is scalene. We get down to part B. Triangle ABC is a right triangle. Why is that so? We notice that AB squared plus BC squared is equal to AC squared. This is called the converse of the Pythagorean theorem. If the sum of the squares of the two smaller sides is equal to the square of the larger side, then the triangle is a right triangle. So AB square root of 45 squared plus the square root of 180 squared is equal to the square root of 225 squared. 45 plus 180 is equal to 225. Now that we know that the triangle is right, we go and we find its area. Let me just remind you the formula for the area of a triangle. Unlucky for us, this is a right triangle. In a right triangle, the base happens to be one of the legs, while the height is the other leg. The area of the triangle is equal to 1/2 times base times height. In our problem, one of the legs is AC. One of the legs is AB, the other leg is BC. So we're going to say 1/2 times the length of segment AC, the length of segment AB, times the length of segment BC. 1/2 times the square root of 45 times the square root of 180. From here, there are two things you can do. You can just take your calculator, enter all those numbers, and get your answer. If you're really good with numbers, you can realize that the square root of 45 is 3 square root of 5, while the square root of 180 is 6 square root of 5. And you can do all of this without the use of a calculator. So this is 1/2 times 18 times the square root of 25. 9 times 5, 45. So the area of our right triangle is 45.